Imagine a place so hostile that it defies the very essence of life, where waters are so dense with salt they suffocate nearly anything that dares to enter. Recently, deep below the Red Sea, scientists uncovered a truly chilling phenomenon: the pools of death. These pools, isolated pockets of hypersalty water, are nearly inhospitable, transforming into graveyards for unsuspecting marine creatures. Yet, these eerie underwater lakes are also a window into some of life's most extreme survival strategies. And, surprisingly, they hold crucial clues for our quest to understand alien life in the universe. This discovery not only intrigues but challenges our very concept of where life can exist. Want more fascinating discoveries? Hit the subscribe button and join us in uncovering the ocean's hidden mysteries. Discovery of the pools of death in the Red Sea. In a 2020 expedition in the Gulf of Aqaba, scientists stumbled upon a mysterious phenomenon in the depths of the Red Sea: the so-called pools of death. These pools, also known as brine pools, consist of super salty water pockets that do not mix with the surrounding ocean water. With salt levels up to 8 times higher than normal seawater, these pools present an astonishing and unique marine anomaly. Such findings intrigue researchers, especially considering the rarity of these hypersaline lakes in the ocean depths. The unique chemistry of these brine pools creates a deadly environment for most marine life. When animals like fish or crabs unknowingly swim into these pools, the extreme salt concentration quickly overwhelms them, leading to rapid suffocation. This results in a haunting underwater graveyard around the edges of the pools, where the remains of marine animals gradually accumulate. The stark contrast between the vibrant surrounding marine ecosystem and these deadly, lifeless pools raises profound questions about the adaptability and limitations of ocean life. This discovery has captured scientists' attention not only for its eerie nature, but also for the geological clues it provides. Because these brine pools are so isolated and distinct, they may serve as natural laboratories, offering insights into rare geological and chemical processes. Studying the composition and formation of these pools could reveal new information about Earth's oceans and marine life, as well as the conditions under which life may have evolved in ancient, extreme environments. This brings us to an even more chilling aspect: the environmental dangers posed by these pools. Dangers of the brine pools. The pools of death present extremely hazardous conditions for nearly all marine life, owing to their extreme salinity and lack of oxygen. When animals like fish, crabs, or even larger creatures unknowingly venture into these waters, they are rapidly suffocated, creating a stark cemetery of marine life around the pool edges. This environment, rich in salt but poor in oxygen, is lethal for most marine creatures, which are unable to adapt to the conditions. As a result, these brine pools function almost as natural traps, wiping out any unprepared species that strays into their depths. What makes these brine pools particularly dangerous is their extreme chemical makeup, which includes toxic concentrations of hydrogen sulfide. This compound is harmful to most forms of life and adds to the deadly nature of the pools. Marine organisms are drawn in unsuspectingly, especially those following food sources, only to find themselves trapped. These underwater death zones disturb the balance of the surrounding ecosystems, as various organisms rely on each other in the food chain. The brine pool's toxic nature disrupts this balance, creating both a physical and ecological divide in these regions of the Red Sea. Despite these dangers, scientists are fascinated by these pools because of the survival challenges they present, making them natural laboratories for studying life's resilience. The conditions in these pools provide valuable insight into how certain organisms cope with, or perish in, extreme environments. This, in turn, could reveal broader biological principles, showing how life can, or cannot, survive in hostile conditions. The origin of these pools reveals even more mysteries, tying their existence to ancient geological events. How the brine pools formed. The origins of these brine pools trace back to the Miocene epoch, millions of years ago. During this period, mineral deposits deep within the Earth's crust dissolved into seawater, creating pockets of hypersaline brine that settled in depressions on the ocean floor. Over time, these concentrated salt pools became trapped in the Red Sea's depths, forming the isolated pools that we observe today. Unlike the surrounding seawater, which flows and circulates, these brine pockets remain stagnant due to their high density, sinking lower in the ocean and creating unique underwater basins. One of the critical factors in the formation and maintenance of these pools is a phenomenon known as freezing point depression. Because the salinity is so high, the freezing point of the water within the pools is much lower than typical seawater, allowing it to remain in a liquid state even in cold ocean depths. This chemical anomaly means the brine pools are effectively sealed off, acting almost like ancient time capsules that preserve the salinity and temperature levels from when they first formed millions of years ago. This stable environment, however, remains unchanged and lethal to most life. The sheer age and geological isolation of these pools offer a rare glimpse into Earth's geological past. Studying the composition of these brine lakes and their sediment layers allows scientists to understand ancient ocean conditions and the types of minerals present. These conditions provide a parallel to other extreme environments on Earth and beyond, which could help unlock secrets about the origins of life under hostile conditions, such as those found on distant planets or moons. These extreme habitats, surprisingly, also support some resilient forms of life. Life that survives against all odds. Despite the lethal conditions of these brine pools, certain forms of life have managed to adapt and thrive along their edges. Microorganisms, particularly extremophiles, organisms that survive in extreme environments, flourish in these high salinity, low oxygen conditions. These microbes have unique biochemical processes that allow them to handle toxic levels of salinity and even absorb necessary elements directly from their surroundings. Such adaptations are rare but invaluable to science, providing a biological blueprint for survival in seemingly uninhabitable places. Some larger creatures, such as shrimp and eel-like fish, also inhabit the fringes of the brine pools. These species do not enter the pools directly but navigate the edges where the salinity is less severe, allowing them to coexist in one of the planet's most hostile environments. Their ability to survive in close proximity to these toxic zones reflects their resilience and adaptability, shedding light on evolutionary survival strategies. Observing these unique creatures allows researchers to understand how life might endure in the harshest conditions, balancing on the edge of survival. This life at the borders of the brine pools is also of significant interest to biologists studying extremophiles for applications in medicine, biotechnology, and environmental science. The organisms that thrive here may possess unique compounds and enzymes that have potential applications, such as in industrial processes that require resilience to extreme conditions. More importantly, their survival gives clues about how life might exist in other inhospitable environments, particularly in outer space, where similar extremes could be present. Relevance to space exploration. The extreme conditions found in the Red Sea's brine pools bear a striking resemblance to the environments that may exist on other planets and moons, particularly those with vast ice-covered oceans like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. These icy bodies are thought to contain subsurface oceans with high salt concentrations, extreme pressures, and low temperatures. The resilience of life in Earth's brine pools suggests that life may also be possible in these distant oceans, where conditions mirror the challenges seen in the Red Sea's depths. Astrobiologists study these brine pools as a model for understanding how life might survive in extraterrestrial settings. The microbes and organisms that can endure the high salinity and toxicity of these environments provide a biological precedent for what may be found in outer space. This connection gives hope to scientists searching for alien life, suggesting that certain planets or moons with similar extreme conditions may indeed harbor microscopic life forms or other resilient organisms. Furthermore, the technology used to explore these brine pools, including remotely operated underwater vehicles, ROVs, and specialized sensors, mirrors the instruments that could be used in space missions. By perfecting these techniques in Earth's oceans, scientists are developing and refining the methods that may eventually be used to explore the oceans of other planets. Thus, these deep-sea expeditions not only expand our understanding of Earth's extreme environments, but also prepare humanity for future space exploration. Significance for marine science and curiosity-driven exploration. The pools of death in the Red Sea are not just scientific curiosities. They challenge our understanding of life's limits and the intricate balance of marine ecosystems. These brine pools create natural laboratories where scientists can observe life's ability to withstand hostile conditions, helping us learn how biological processes function in extreme environments. These pools, where intense salt levels prevent life for most organisms yet allow others to thrive on the fringes, serve as perfect examples of nature's resilience. The more scientists uncover about these unique ecosystems, the more they can understand the possibilities for life in environments previously deemed uninhabitable. These discoveries also contribute to our knowledge of the Red Sea's geological history, as the pool's mineral compositions reveal clues about ancient seas and climate conditions. Through sediment analysis, researchers can piece together changes in the Earth's geology and climate over millions of years. This provides insight into how global factors like temperature, ocean currents, and tectonic shifts have influenced the development of marine life and even human history. By understanding these pools, scientists get a glimpse into Earth's past and how marine systems have evolved alongside changing environments. Curiosity-driven exploration, fueled by advances in underwater technology, is essential to uncovering more mysteries like the pools of death. Without these expeditions and the sophisticated equipment that makes them possible, phenomena like these pools would remain hidden. As scientists continue to explore, new ecosystems, geological formations, and potential applications for human life are discovered. In this sense, the Red Sea's brine pools not only deepen our knowledge of marine life, but also ignite a broader curiosity that fuels ongoing discovery and technological innovation. The discovery of the pools of death in the Red Sea forces us to redefine what we think of as habitable. As we venture into these depths, we begin to uncover powerful lessons on adaptation, resilience, and the hidden potential of life. Could these eerie underwater graves unlock secrets for future explorations, both here on Earth and across the cosmos? What we learn here could change everything, from the way we understand marine life to the possibilities of extraterrestrial existence. So, are you ready to dive deeper into these mysteries with us? Remember to subscribe and turn on notifications to stay connected as we explore the unknown. Stay curious. Don't forget to subscribe for more deep dives into science's most astonishing discoveries.